Hello everyone, today we're going to go over some review problems, just some problems for you to practice on your own and then continue watching to see the solutions. Very similar questions will be on your test on Friday. So go ahead and pause the video right now. For number one though, when I say use a limit definition of the derivative, you have a choice as to what formula you wish to use. So go ahead and pause the video, give this a try. But remember to communicate everything that you're doing here and then resume playing, and I'll go over. I'm going to show you a couple ways depending on which method you decided to use. All right, so one is if you find, or if you use f prime of a, this is going to be the limit as x approaches a of f of x minus f of a over x minus a. Now what's nice about this version for this one, because we're finding it at a specific x value, so since you have this already written out, which I would expect to see this, then you would show f prime of 3, and all the a's get replaced by the 3. So the limit as x approaches 3, f of x minus f of 3 over x minus 3. So now f of x was the 3x squared minus 7x plus 4. F of 3 will give us a 27 minus a 21, which is 6. 6 plus 4 will give us a 10. And remember, if it was a negative 10, we'd have minus a negative 10, which would turn into a plus 10. And then over x minus 3, combining our constants up above, we have 3x squared minus 7x minus a 6 over x minus 3. Now it comes down to factoring. And one nice clue is we want that denominator to be able to divide out, so a factor in the numerator needs to match that. So as I factor this, I'm going to have 3x and x. So here's my x. Chances are that's going to be the x minus 3. And then if I put a plus 2 here, that's going to work. We're going to get a 3x squared minus 9x plus 2x will give me a minus 7x and then minus 6 over x minus 3. So the x minus 3's divide out. I'm still left with the limit as x approaches 3 of 3x plus 2. Now I could do direct substitution. So f prime at 3 is going to equal 11. So that was pretty simple, a little bit of factoring involved. Now if you used one of the other two, which are pretty much the same, you're finding f prime of x, which is the limit as delta x approaches 0 or h approaches 0. H is a little bit easier to write and work with, so we're going to write this out. Here we have f of x plus h minus f of x all over h. So we're going to have 3 times the quantity x plus h squared minus 7 times x plus h plus 4. Then minus our f of x, so that's 3x squared minus 7x plus 4 all over h. So I need to expand the binomial first. I'm going to have 3 times, this will give me an x squared plus 2xh plus h squared minus 7x minus 7h plus 4, then minus a 3x squared plus 7x minus 4 all over h. Now at this point, if it helps, and it will, we can cross out what's going to cancel here. 7x's are gone, and then the 4's are gone, so we have a little bit less to write. I'm going to go ahead now and distribute my 3. So we're going to get a 3x squared plus 6xh plus 3h squared minus 7h minus 3x squared all over h. Our 3x squared should cancel now. I still need to write the limit as h approaches 0. I'm going to go ahead and divide the remaining numerator terms by h. So this will give me a 6x plus 3h minus 7. As h goes to 0, I'm going to just be left with a 6x. So f prime of x is equal to 6x minus 7. F prime of 3 will become 18 minus 7, which is an 11. So they both match here. Now you can also just, now that you know the shortcuts, you could just check this too. Again, on the test, I'd expect you to show all the work for one version or the other, but if you know f prime of x, using the shortcuts, will become a 6x minus 7, and then you can substitute the 3 in and you would get an 11 that way. So you can always check now that we definitely know the shortcuts. All right, go ahead and take a look at number 2. Pause the video. Actually, 2 and 3 are together, so you could work on both of those right now. Pause the video and then resume playing. All right, so let's take a look at number 2. Here we could use the shortcut rules to help us out here. We do not have to go through the limit definition of the derivative. So here, I want to find the slope of my tangent line, which is y prime, which will just become an 8x minus 2. Then at x equals negative 1, y prime is going to become a negative 8 minus 2, which is negative 10. So the slope of my tangent line at x equals negative 1 is negative 10. So in order to write an equation, I need the slope, which we have. Now we need the point. So right now I've got the x value. I need to find the y value. So at x equals negative 1, we'll find y is going to equal 4 times negative 1 squared minus 2 times negative 1 plus 3. So this will give me 4 plus a 2 plus a 3, so it's 9. So my ordered pair is negative 1, 9. Now I go to write the equation. And again, because point slope form is accepted, we could start with this. We could say y minus y1, so y minus 9, is equal to the slope rather, so negative 10 times a quantity x minus a negative 1, so it becomes an x plus 1. This is acceptable. Or if you want to put this in slope-intercept form, we're just going to distribute the negative 10, so we're going to negative 10x minus 10 plus 9, so we get a y equals negative 10x minus 1. Both of those are acceptable. So the only difference here with the normal line is that it's perpendicular to the tangent line at that same point, negative 1, 9, so we already have our point. We just have to change or adjust our slope. So this will give us a positive 1/10. So now writing the equation, again, point slope form, we're going to start with y minus 9 equals 1/10 times the quantity x plus 1. And we're done. If not, you can distribute the 1/10, so we're going to get y equals 1/10 x plus 1/10 plus 9. So we're going to get 1/10 x. This will give us 90 tenths, so we'll say 91 tenths. Or you could just put it together as 9 and 1/10. That's perfectly fine. So there's the equation in two forms for our normal line. All right, another problem, find the equation of the tangent line to the curve y equals 5x over x squared minus 1 at x equals 2. So pause the video to work on this one. All right, so we need to start, again, finding the slope of our tangent line, which is y prime. We have to use the quotient rule here. So we're going to go low d high minus high d low over low, low, so our denominator squared. And then we'll simplify this, so we're going to get a 5x squared minus 5 minus a 10x squared all over x squared minus 1 squared. Simplify the numerator, so we're going to get a negative 5x squared minus 5 all over this. Now there's two things we could do. Because we're finding it at a specific x value, we could simplify this. If not, it is perfectly fine to leave it like this and substitute the 2 in. But to make life a little bit easier, let's just try. If we factored out a negative 5, we're left with an x squared plus 1, and that does us no good. So we can just go ahead and leave this right here. So now, at x equals 2, y prime is going to become negative 5 times 2 squared minus 5 all over 2 squared minus 1 squared. So that's going to give us a negative 20 minus 5, so we get a negative 25. And this will give us 3 squared, so 9. So the slope of our tangent line at x equals 2 is negative 25 ninths. To finish the point, right now we have still 2 comma whatever. This will become the point. We'll get a 10 over 3, so 10/3 is the y value there. All right, so again, to write the equation out, we'll say y minus 10/3 equals negative 25 ninths times x minus 2, so that works, or we could put this in slope-intercept form. So we could say y equals negative 25 ninths x plus 15 ninths. And then as I add 10/3, I'm just going to add 30 ninths. So now this becomes y equals negative 25/9 x plus 89. And that is the slope-intercept form. All right, so just practicing some more using the quotient rule to help us find the equation of a tangent line at a certain x value. All right, please make sure you go back over GIFs 3, parts 1 and 2. Please let me know if you guys have any questions. Also, the packet of 1 through 8 sketching graphs of derivatives. So again, the test is on Friday. In yesterday's lesson, I went over all the topics. It's going to be about 10 problems, around 45 points. And then, so next week, we have a 4-day week. And then you guys have a 4-day weekend. So it should be Tuesday the 3rd. I'm going to plan for a quiz over the 12 days of log. So make sure you guys are going back to look at that. All right, also, if you have any questions from any other assignment, any parts of the assignments, please let me know. On the next couple pages, I've got the solutions to pages 120 and 121. I'll post that as a separate PDF. Still, please take the time to go through the Inspired doc, either on your calculator or watch the video for 3.4 rates of change. So now on in Google Classroom, if you guys take a look, so let me bring this up, but I'll put this on a separate PDF as well. These are now AP practice problems. We're going to start looking at multiple choice. First multiple choice, no calculator. Some of them will have calculators. So these are going to be the specific page numbers and the problem numbers. Please make sure you keep a separate section for all of the AP practice problems I assign. Show all necessary work. Now, typically the average time for a multiple choice non-calculator, you should have about 2 minutes. And then for a calculator problem is about 3 minutes. So I'm going to go ahead and take it to Google Classroom just to show you where this can be found at. All right, so once you guys are in Classroom, just go to classwork. I started a new topic now because this is going to be with us for all year. So it's going to stay at the top. So if you click on the AP practice problems, okay, finally got it to come up. And then just hovering over each one, if you hover over it, you're going to see the pages right here. So what I have first is just the first 34 pages scanned in, and then if you go over, there's 35 through 90. If there's any pages omitted, some were intentionally left blank. So right here, there's 91 to 131. And here, so there's nothing on page 132 here. But this is all of the problems. Anytime I assign AP practice problems, this is where you can find them. This is how you can access them. In class, I actually have binders on the shelf with them. So if you guys prefer an actual copy, I can send them home with you. So especially my remote learners, if there's a way you want me to get you the actual binders, that's fine. If not, this is the virtual version of the binders. All right, so again, here are the problems that you want to do. So everything is going to be within the first page here. Notice here on page 31, though, you can use a graphing calculator on. Everything else do without a graphing calculator. And then, like I said, here are the even answers to pages 120 and 121. I'll scroll down. But these last couple pages I'll have as a separate PDF in Classroom. So here's all the problems with the work or explanations. Now for 28, this is more of an AP style question, but it was asking where does the smallest slope of the curve occur? So it occurs when the 3x squared plus 1 is minimized. And it has here, what I have written in here, the x value of the point with the smallest slope will be the x which makes the expression as small as possible. And then over here, since 3x squared is always non-negative, 3x squared plus 1 has a minimum value of 1, which is achieved at x equals 0. All right, so take care, guys, and let me know if you have any questions.